Okay, today we are going to discuss our previous lecture, which I think so have some slides left behind. Okay, do you have any idea how much have we done and any queries regarding your previous lectures or anything that comes into your mind as a query or a thing that is that's required to get discussed in this class?
No, sir.
All right. Okay, now Umar, are you here?
Yes, sir.
Okay, kindly tell us what is ERD?
It's entity relation diagram.
Okay, why we use ERD?
I don't know, sir.
All right. Ayaz, are you here?
Yes, sir.
Kindly tell us why we use ERD.
To show relation between columns and rows and columns with the data.
Okay. Jahid, are you here? Okay, Ayaz. Basically, we have to use ERD to conceptualize our database model, or you can say it is used to display our database model on a paper, or it is an idea of our database model, how our database will get to design. Okay. The words that you have mentioned with your explanation is also true, but at somehow you have to make it more comprehensive with your words. Okay. Umar,
Okay, sir.
did you get it?
Yes, sir.
All right. Now we are going to start our lecture, which is left behind. Conceptual, logical, and physical data models. Basically, we have three types of data models on the basis of which our database will get designed. An ER model is typically drawn after three levels of abstraction, which one is conceptual ERD, means your conceptual data model, logical ERD, your logical data model, and physical ERD, at where you are going to deploy your database with queries. Okay. While all three levels of ER models contains entities with attributes and relationships, they differ in the purpose they are created for and the audiences they are meant to target. Basically, the conceptual ERD is only for developers and designers and stakeholders. Stakeholder will give you some requirements. Designer will get the design or design the schema, how the concept will get implemented. Then designer and developers, both or sometimes developers produce a logical ERD with some logical reasoning that our our database will get deployed in these three stages. The graphical representation of relationship between different entities. Mujahid, stay update. You have to answer while we are asking from the class. Okay, stay updated. So this is how we are going to create our ERD for their references or reference audiences. A general understanding to the three data models is that business analysts use a conceptual and logical model to model business object exists in the system. Basically, businessmen have a business analyst that the one person who will analyze the graph or business representations or business preparations to take some decision by the stakeholders. So they will better understand how the database or how our data model will get worked. While database designer and database engineer elaborate the conceptual and logical ER model to produce a physical model that presents the physical database structure ready for the database creation. Okay. Conceptual data model. Conceptual ERD models the business object that should exist in system and the relationship between them, because no one knows the business from the owner of that business. Okay, every business have a separate data model. Every business have some separate operations. They might they might be same in the entire industry, but the operation or the operational tactics will get the difference that will lead their business into the industry, just like the Amazon and AWS servers. The design is same, the owner is same, but the operations are a little bit different, and both the services are much different. A conceptual model is developed to present an overall picture of the system by recognizing the business object involved. It defines what entity exists, not which tables. For example, many-to-many relationship tables may exist in logical or physical data model, but they are just shown as relationship with no cardinality under the conceptual data model because they have no existence. Conceptual ERD support the use of generalization in modeling a kind of relationship between two entities. For instance, triangle is a kind of shape. The usage is like generalization in UML. UML is basically unified modeling language in which you are going to model your database design or software design logically with some logical notations. Notice that only conceptual ERD supports generalization. Here, customer and product both have many-to-many relationship. A customer may have many products, and a product is demanded by many customers as well. And at the same time, as one product is get supplied from the one supplier, because store have huge choice that they will get many suppliers with the same product. Logical data model. Ayaz, can you read it?
Yes, sir. Logical ERD is a detailed version of a conceptual ERD. A logical ER model is developed to enrich a conceptual model by defining explicitly the columns in each entity and introducing operational and transactional entities. Although a logical data model is still independent of the actual database system in which the database will be created, you can still take that into consideration if it affects the design.
Okay. Do you get that? All of you,
Can you
any
simplify
question
it?
in this?
Sir, can you simplify a little bit like what they're saying?
Yeah, sure. Okay, logical ERD. It means you are going to design conceptual ERD and transforming conceptual schema into logical. Okay, a logical ER model is developed to enrich a conceptual model, means you are going to transform your conceptual schema or your conceptual idea into the actual logical model by defining explicitly the columns in each entity, which type of attributes you are going to deploy in your tables of your database, which type of data this table or any table in your database will get hold, and introducing operational and transactional entities. And you are going to introduce what will be the operations. Either you want to do some search, either you want to do some update. These are the transactions. Although a logical data model is still independent of actual database. Why? Because logical data model have some limitation, and actual database system will get operate in the real time, which also have some separate limitation, in which database will be created. For example, you have designed your schema into Oracle, but the developer or designer will deploy the schema or deploy the database in MongoDB, then what will you do? You can still take that into consideration if it affects the design. That's how your design will get affected, but the operation will get the same. Okay, MongoDB, which tier of database? We have discussed that the tiers of database, I think so, or the levels of database, right? The structure of database, from where
Yes, sir.
or which structure MongoDB belongs. Logical data model. Columns attributes are defined here. A new entity order is added to the model. The purchase operation performed by the customer. These are the operations. These are the some transactions. Umar, you have to determine, okay?
Yes, sir.
You have to determine either is a file structure, either is a some other structure, either is a table structure, no SQL, queries form, or whatever that you can discuss. Okay, physical data model. Physical ERD represents the actual blueprints of relational database. Now the blueprint is developed. You have to design your physical data model. A physical data model elaborates on the logical data model. Now you are transforming logical data model means logical EID into actual database by assigning each column with type, length, nullable, etc. Since a physical EID represents how data should be structured and related in a specific DBMS, it is important to consider the convention and restriction of the actual database system in which the DB will be created. If you are creating it in the Oracle, then you should have to keep in mind the convention and the restriction. If you are creating it into the MongoDB, then you should have to keep the conventions according to the MongoDB protocols. They have a little bit of difference, just like MySQL and SQL, just like PHP, MyAdmin, and Oracle, but you have to take care. Make sure the column types are supported by the DBMS and reserved words are not used in the naming entities and columns. Reserved words. What are the reserved words? Foreign keys, primary keys, just like this, okay? You should not add these type of words into the column. How to draw ERD? Try to follow the step below to understand how to draw ERD effectively. Umar,
Yes, sir.
kindly read it.
Try to follow the steps below to understand how to draw an AID diagram effectively. Make sure you are clear about the purpose of drawing the AID. Are you trying to present an overall system architecture that involves the definition of business objects, or are you developing an EID model ready for database creation? You must be clear about the purpose to develop an EID diagram at the right level of detail. Make sure you are clear about the scope to model. Knowing the modeling scope prevents you from including redundant entities and relationships in your design. Draw the major entities involved in the scope. Define the properties of entities by adding columns. Review the EID carefully and check if the entities and columns are enough to store the data of the system. If not, consider adding additional entities and columns. Usually, you can identify some transactional, operational, and event entities in this step. Consider the relationships between all entities and relate them with proper cardinality. Example A1 to many between entity, customer, and order. Don't worry if there are orphan entities, although it's not common, it's legit.
Okay, here. What are the orphan entities? Basically, these will form when we are going to break down many-to-many relationship into one-to-many relationship. That's why it says a one-to-one, one-to-many between entity, customer, and order. We have done many-to-many relationship because one customer can have many orders and many orders can have many by the many customers. You know that. Umar, carry on, please.
Apply the technique of database normalization to restructure the entities in a way that can reduce data redundancy and improve data integrity. For example, the details of the manufacturer might be stored under the product entity initially. During the process of normalization, you may find that the detail keeps repeating records over records. Then you can split it as a separate entity, manufacturer, and with a foreign key that links between product and manufacturer.
Okay. Any question or any query in this slide? Ayaz, are you clear? These are in very simple English. Umar, do you have any query in this slide?
Sir, can you explain the last point?
Okay. Apply the technique of database normalization. What is normalization? Do you know about that?
No, sir.
It's okay. Basically, normalization is a term is used to break down the tables where tables are large enough means tables have more than 5 or 6 columns, or you can say there are enough columns in the database entity. Basically, entity is a table and the columns are the attributes. A table can hold multiple and many attributes, or you can say columns. But if there is a lot of columns in an entity, then we should have to break this entity into many tables. These tables will be interconnected with one-to-one relationship. One-to-one relationship is used to get connect many entity tables so that there should be one record in the entire entity and will be stand alone, means there will be no duplicate record in the entire entity or the entire table, and your data is safe and will get searched very fast in the normalization. So apply the technique of database normalization to restructure the entity. This will give you an idea how your database table will get split into many of these, and then you have to restructure according to your requirement or need the entities in a way that can reduce data redundancy. Basically, when you feel or you see duplication of data or duplication of columns data, duplication of rows data in one entity or one table in the entire table, then you can say this is data redundancy. So you have to reduce data redundancy and you must have to keep one same record at one time. Means there will no duplication of data and there will be single data in the entire table of the database. And improve data integrity. Data integrity means there should be accurate data in the columns or attributes of the tables. For example, the details of manufacturer might be stored under the product entity initially. Means product, manufacturing date, who will be the manufacturer in this regard. During the purpose of normalization, you may find that details should be kept separate and manufacturer details should be kept separate, and these tables will get connected with one-to-one relationship. You may find that details keeps repeating records over records. So this, okay, Umar, can you tell us if the record is repeating over and over in the one table or in the entire table, then which type of you can say phenomena is this? Which type of situation is this?
So it will be like database normalization.
No, it's data redundancy. We have just done that. If data gets duplicated over and over or repeat itself over and over, then it is data redundancy and we should have to reduce it. Then you can split it into the separate entity, means separate table, manufacturer table, with a foreign key that links the table product and manufacturer. Okay, and these two tables are connected with one-to-one relation. Okay,
Yes, sir.
and we move next.
Yes, sir, we can.
Okay, here's the example of ERD. You can check it out, and if there is something that you want to know, or there is something that you did not understand, then you can ask. Okay, do you want to ask something? Umar and I ask, do you have any idea Crawford and simple line terms?
Can you repeat the question, sir?
Do you know about Crawford and the single line term?
No, sir.
Okay, Umar, do you have any idea?
No, sir.
Okay, basically here you can see that where we have Crawford means, okay, where you have Crawford, it means it is indicating many relationship to the entity. Here you can see that a single line, it seems it is one relationship and combinedly it is one to many relationship from category to film category. Category holds one and Crawford film category holds many. So it's a one to many relationship where we find slightly fade lines. It means it is weak relationship or the relationship from the weak keys. Okay, where we find good lines means black color lines. It means it's a strong relationship and these tables have strong connection. Okay, so did you get that?
Yes.
Any query?
No, sir.
Okay, here is a ERD of loan system. You will check it out and we will discuss it in the next class. Okay, guys, both of you. Okay, and
Yes.
convey it to the Mujahid too. Okay, now we are going to discuss DFT. I ask, can you read it?
Okay, sir. DFD. DFD is the abbreviation for data flow diagram. The flow of data of a system or a process is represented by DFD. It also gives insight into the inputs and outputs of each entity and the process itself. DFD does not have control flow and no loops or decision rules are present. Specific operations depending on the type of data can be explained by a flowchart. It is a graphical tool useful for communicating with users, managers, and other personnel. It is useful for analyzing existing as well as proposed systems. It provides an overview of what data is system processing, what transformation are performed, what data are stored, what results are produced, etc.
Okay, want to get explained? Guys, do you need explanation?
Yes, if you could explain it a bit.
Yeah, sure. I will make it simpler to you. Okay. Basically, DFT is a graphical representation of your data model. Okay. It is a graphical tool that will communicate with user manager and other personnel. Means, for example, if you are developing for your manager, for your organization, for your users, then you can show the DFD to them, in which it says the flow of data of a system, the entire system, how the data will get flow from right, from user end to the back, from up to bottom, will get be represented into this DFT. It also it also gives insight into the inputs and outputs of each entity and process itself. It will give you an overview of how it will take the inputs and show outputs and how it will process the data itself. DFD does not have control flow through which you can do some controlling. No loops. You cannot repeat or decision rule. You cannot specify specific operations depending on the type of data can be explained by the flowchart. Its flowchart will give you an overview of some specific operation. For example, in the banking management system, DFD of ATM will give you some specific operation of ATM, how the transaction of your data from bank account will get at the cash, means at the end it will convert it into the cash and you will get some cash into your hand, how it will get processed. So these are the things that will show the D into by that DFD, by the developer, by the designer, how you are going to use, how system will work, how our system will get manage your data. Okay, it provides an overview of how data your system is processing, how transformation are performed, means your bank balance converted into cash, what type of data is stored, what are the results that is produced. You can ask if you have any query. We will move next. Now we will discuss components of DFA.
Yes, sir, visible.
All right, we should move next. Components of DFA. The data flow diagrams has four components. The first one is process. Input to output transformation in a system means from getting input and transform it into output in a system takes place because of process function, because we have some functions to this that will process the input. The symbols of process are rectangle with round corner, oval, rectangle, or a circle. These are the symbol of process in the DFT. The process is named a short sentence in one word or a phrase to express its essence, has a function. Okay, has a function. This is the example of process. Data flow. Data flow describes the information transferring between different parts of the system. The arrow symbol is the symbol of data. A relatable name should be given to the flow to determine the information which is being moved. Data flow also represent material along with information that is being moved. Material shifts are modeled in systems that are not merely informative, means they should not have to be in system, but they are useful. So that's why we are keeping in the system, but they are not informative. You should just have to know about it, not they are not necessary. A given flow should only transfer a single type of information. It means in one time you can transfer only one transaction from your place to any part in the world. Okay, you can transfer only one transaction. You can do only one transaction at a time from your cell phone or your bank account to any part in the world. The direction of flow is represented by the arrow, which can be also a bidirectional. For example, input and giving an output both are bidirectional. If you do input as a reaction or as a processing of information, system will give you an out. Okay, so the direction of flow of information or the direction of flow of process is bidirectional. The first flow the user initiated from itself or herself or himself externally into the system, then system process the information that get by the input, and then it will display a output. Okay.
Okay.
Okay, thank you. Components of DFD. Third one is warehouse. Warehouse, you can say your database or the data where your data will get stored on the memory. Warehouse, the data is stored in the warehouse for later use. Two horizontal lines represent the symbol of store. The warehouse is simply not restricted to being a data filer. Rather, it can be anything like a folder, an optical base, or a filing cabinet, or you can say a USB. The data warehouse can be viewed independent of its implementation, means you can say anything about data warehouse. For example, if you're storing data on the hard disk, then it's a data warehouse for you. If many scientists maintaining a servers, or you can say a huge server system for storing data, you can say it's a data warehouse, just like the Google. If you are storing the data on USB, then the USB will be the warehouse for that data, and vice versa. When the data flow from the warehouse, it is considered as data reading, and when data flows to the warehouse, it is called data entry or data updation. Okay. Terminator. Terminator is an external entity that stands outside of the system and communicates with the system, just like the user that is requesting from its cell phone to the server of some educational site to download some slides of study material or whatsoever. It can be, for example, organizations like banks, group of people like customers, different departments of same organization which are not the part of model system and is now an external entity that wants to communicate with the system out from the outside of the system. Okay, for example, tax holder department or tax department or accounts department officer comes to an IT guy and requests that kindly store our this data into your system. So the accounts officer is the terminator and the IT guy is in the system man. Okay, system that holds the records of that department or that entity into the office. Entity means here, entity means man. Okay. Modeled systems also communicate with terminator. For example, you store the accounts officer data. Now you give an output that your data is stored safely. So this is the communication that system do at its end to the user by means accounts board. Rules for creating data flow diagram. Yes, are you here? Can you please read it?
Yes, sir.
Kindly read this slide.
Rules for creating DFD. The name of the entity should be easy and understandable without any extra assistance like comments. The process should be numbered or put in ordered list to be referred easily. The DFD should maintain consistency across all the DFD levels. A single DFD can have a maximum of 9 processes and a minimum of 3 processes.
All right, Alden, should I explain?
No, sir.
All right, we should move now. If you feel any query in any slide, then you can ask, okay? Okay, Umar, can you please read it?
Yes, sir.
All right, go ahead.
Symbols used in DFD. A square box. A square box defines source or destination of the system. It is also called entity. It is represented by rectangle, arrow or line. An arrow identifies the data flow. It gives information to the data that is in motion. Circle or bubble chart. It represents as a process that gives us information. It is also called processing box. Open rectangle. An open rectangle is a data store. In this data is stored either temporary or permanently.
And are these some symbols that we use in DFT data stores? Okay, we have some arrows, external entity, data flow, sorry about that, process, how we are going to process. Okay, these are the notations that is expressed by Jordan and Cord and Gain and Sarson. These are some guys that use these notation to specify the operations or things that you are going to display in DFD. So these have their own notation. We should follow Jordan and Code or whatsoever. What else you need to get followed? But it will be a little about that. You should have to follow any one of these, but you should know about the benchmarks. Okay. Ayaz, please read it.
Levels of DFD. DFD uses hierarchy to maintain transparency. Thus, multi-level DFDs can be created. Levels of DFD are as follows. Zero-level DFD. It represents the entire system as a single bubble and provides an overall picture of the system. One-level DFD. It represents the main functions of the system and how they interact with each other. Two-level DFD. It represents the processes within each function of the system and how they interact with each other. Three-level DFD. It represents the data flow within each process and how the data is transformed and stored.
Is it okay? Or should I explain?
Yes, sir. Can you explain?
It says let's use hierarchy to maintain transparency. Zero level, one level, two level, and three level. At zero level, it says entire system is uh, will be shown as a single bubble and provides an overall picture that it is processing something. At first level of TFT, it represents these are they here we have some main functions. For example, inputs, processing, and then show output. These are the basic and the main functions. Then it will also show how they are going to interact. For example, let's say after getting input flow towards the processing unit, and processing unit process the information from the input, and again it will forward the information towards the output. At second level of DFD, it represents the processes within each function of system. Now you are going to expanding the view, like in the student management system, signing in process. You are going to check how signing in process will be created, which type of process of functions are get deployed, and how they interact with one another, how the sign information will get stored, how the information is traveling from front end to back end, what is the transferring of code. At third level of DFT, it represents the data flow within each process and how the data is transformed and stored. Now, you are going to check each and everything in the entire system. Let's say, if we talk about finance system, or you can say banking system, how user creates accounts, how the account information or the identity in the identification numbers are getting stored in the database, how we are going to validate it, how the user is submitting some income or money into our bank account into our bank with the account holder name, how the transactions are getting performed, how each and everything get managed in the entire system, and how transactions are getting managed from one user to another user's account, just like transferring of funds from one user account to another. Okay. So at third level of DFT, you are going to discuss each and every process of the entire system. Okay.
Yes, sir.
All right. Do you have any query till now? Any type of query?
No, sir.
Okay. Now, if we talk about zero level DFT, DFD level 0 is also called context diagram. Okay. It's a basically overview of a whole system, the most basic overview of whole system or the process being analyzed or get modeled. It is designed to be at a glance view, showing the system as a single high-level process with its relationship to external entities. It should be easily understood by wide audience or the basic audience or the end users or the public, including stakeholders being business analysts, data analysts, and developers. Basically, they don't have to get to know about the zero level DFT. Stakeholder and business analysts always check zero level diagram, and designer and developers should know about third level of DFT because the core objective is to manage, to optimize, and to control all the functions in the entire DBMS. First level of DFT. DFD level 1 provides a more detailed view of zero level DFD. Okay. Level 1 provides a more detailed breakouts of pieces of context level diagram, means zero level diagram. You will highlight the main functions carried out by the system as you break down the high level process into context diagram into sub process. If we talk about, if let's say I ask, if you process information at some user end, it will be zero level DFT. If you store, process, manage, and search while purify the information at the back end or at the you can say at the core backend, it will be third level DFT. But if you manage the information just to transfer from backend from front end, it will be first level DFT. If you want to more to know more, then you will check how this function will get found. If you are investigating the function processing, then it will be second level DFT. Okay, DFT. Now it's done. If you have any idea about how the system of you can say LMS, let's say an example of LMS. Do you have any idea how the LMS works? Can we draw DFDs, three level of DFDs about LMS? Can we?
Yes, sir.
Yeah, but there are some systems that we cannot define up to three levels of TFT. That may be weather forecasting system. I think so. I am skipping something, but there are some security servers or there are some security system or software that cannot show your third level DFT. They will only show up to first or second level DFT. You want to know the examples of second level DFT that holds the second level of DFT? Is it so? There are some systems that don't show up to second level or third level DFT. These are some security software or these are some security servers or security type of codes or you can say scripts that involve some security or you can say your country security or some intelligence or some these type of protocols that can show you second level of DFT or up to third level DFT. They will show only first level up to first level of DFT. Okay, just like surveillance system. Okay, are you good?
Sir, can you explain this again?
Yes, I am saying that there are some software or DBMS or some other data warehouse that cannot show you second level or up to third level DFT. Why? These are belongs to some security protocols or some intelligence or from some surveillance system. Okay, these are
Okay,
kept,
sir.
these are kept secret for some intelligence purposes. Third level DFA. Umar,
Yes, sir.
can you please read it?
Progression to level 3, 4, and beyond is possible, but going beyond level 3 is uncommon. Doing so can create complexity that makes it difficult to communicate, compare, or model effectively.
When we are on level 3, we will check each and every function, each and every process by ourselves. But if we talk about 4 or next levels, then we are talking about communication and it will make it complicated. Why? Because maybe it is some support of online service, or it may get support from the API, or it may be get help from some other server, or you can say inter-server system. Maybe this database or the database that you are going to design may be interoperable into intranet. So in this way, it makes you more difficult and it makes you more difficult for your investigation into your DFD's level. Okay. Okay, Abu Bakr, are you here?
Yes, sir, I'm here.
Kindly read it.
Data dictionary. The data dictionary is a collection of names, definition, and attributes about data elements that are being used or captured in a database, information system, or part of research project. It describes the meaning of the purpose of data elements within the context of a project and provides guidance on interpretation, accepted meaning, representation, and data dictionary also proves the metadata about data elements. The metadata included the data dictionary can assist in defining the scope and characteristics of a data elements as well as the rules of their usage and application. Do I continue, sir? Okay, sir, got it. What does the data dictionary consist of? The data dictionary consists of the following information: name of the table in the database, constraints of a table, for example, keys, relationship, etc., columns of the table that are related to each other, owner of the table, last access information of the object, last updated information of the object.
All right. Data dictionary. Data dictionary, as from name shows, it's a collection of names, definitions, and attributes about the data elements that are being used or captured in the database, information system, or part of research project. What are the data elements? Now, Omar will tell us. Yes, can you tell us
Sir, can you repeat the question?
what are data elements?
I don't know, sir.
Basically, data elements are, you can say, int, okay, date. These are data elements that will control the data from getting right into. Okay, it describes the meaning and the purpose of data elements within the context of project and provide guidance on interpretation, accepted meanings and representations. For example, what if name should get stored in string? What will happen? Only first letter of your number will get displayed. A data dictionary also provides metadata about data elements. Metadata is the data that is related to the data that is stored into your database. A metadata include in a data dictionary can assist you, developers and designers, in defining the scope and the characteristics of data elements as well as the rules of their usage and application. Int is the data element, and the metadata is you can store up to 266 characters of integer into your database. Just like the name, you can store up to 266 characters. Date type data you can store in the format of the date. So it will assist you to determine the scope, the characteristics of your data. The data is stored into the date format. Data is stored into the integer type format. What data dictionary consists of? Now your data dictionary include name of your tables, means entity in the database. Constraints of a table means your keys, your relationship, primary key, foreign key, composite key. Okay, there is a key that can be a primary key, but is not. But what is that key name? Abu Bakr, Umar, Ayaz, can you explain me?
Foreign key, sir.
There is a key that can be primary key, but is not. Can you name the key?
Yes, sir, I think it's foreign key. Foreign key.
Umar, can you please explain us? There is a key that can be a primary key, but not. What is the name of
No, sir.
Abu Bakr? Can you please explain what we have discussed? It can be the primary key, but we will select only one key as a primary key. The remaining one will be the candidate key. Did you remember? Ayaz, Umar, I think you were in the class. Do you have any question? Okay, we will complete it. Constraint of table means keys, relationships, columns of the tables that related to each other. Owner of the table, last access information of the object, last updated information of the object. Object means table. We will close this lecture till data dictionary. We will move further in the next class. Do you have any query? If not, then thank you. Take care of yourself and study on time. Take care. Allah Hafiz. If you feel any query, then you can ask anytime.